Perfect. So let's get started. As I said, everybody, really great to see you all here for our first workshop of the day. We do have another workshop at 5:30 BST UK time. But yeah, we're all really excited that you've decided to join us today. As always, please do continue to reach out to us, whether it's on Discord, whether it's on Calendly, booking in calls. It's really great to hear how your project building is going, and also important to hear any issues you are having. I've seen lots of questions in the SpruceID chat, which Sam has been answering. So that's a really great way to get answers for your project. I only have one announcement today before I hand over to Sam, but that is unfortunately the SORT workshop tomorrow has had to be cancelled. However, instead, we are running a team formation workshop. So for anyone who is looking for team members to help them build during this university hackathon, that's a really great opportunity for you to come along and network with some of the other hackers involved, and yeah, ultimately form your teams going forward. So we do look forward to see you all there. The calendar invites have been updated, so you can just join the invite which you have in your calendars already. But that's everything from me. So without further ado, I'm delighted to introduce Sam from SpruceID, who will be talking to us today about using open source to power your app with decentralized identity. So Sam, thank you very much for joining us, and I'd love to hand over to you.
Cool. Thanks for the great intro, Rory. Like Rory mentioned, I'm Sam Gbafa. I'm a senior software engineer at SpruceID. And yeah, here to talk to you guys about using open source to power your app with decentralized identity. So for today's session, this is our agenda. First, we're going to kind of talk about what SpruceID is, what we do. We're going to talk about SpruceKit, our suite of open source libraries. We'll talk about hackathon bounties, like the prizes and our judging criteria. And then we're going to do a live walkthrough, kind of like a cheat sheet for participating in our bounties. It'll kind of be a way to see how to use the libraries and like what's possible. And afterwards, we'll have an open Q&A. So yeah, let's dive in. So first, let me give an intro to who Spruce is as a company, SpruceID. So at Spruce, our mission is to let users control their identity and personal data across the web. We really believe in people being able to control their own data. I would call myself, and a lot of Sprucers call ourselves, user control maximalist, where users are able to control as much of their data as possible. So instead of having people signing into platforms and putting all their data to the platform is signing into you and accessing data with your permission. So who do we work with at Spruce? We kind of have two sides. On one side, we work with large organizations like government agencies, and they use our product Credible. So Credible is all about managing an entire lifecycle for digital credentials, from issuing them to using them in the field. And so, yeah, that's a really big part of what we do. But we also have another part, which is kind of more our Web3 side, where, and that is kind of covered under SpruceKit. So SpruceKit is our suite of open source libraries, and we'll talk about that a little more, learn all about it. So actually, before we hop in, there's a couple concepts that I want to share, just so we have a common language when talking about credentials and identity and everything. So the first thing I want to share is the idea of a trust triangle. So trust triangle is a framework that we use in the context of digital credentials. So this is basically a framework where you have an issuer of the credential. It could be someone like a government, or it could even be something like a DAO issuing this credential. You have holders of the credential, the people who are having the credential. So let's say the DMV issues me a credential that's a digital driver's license. And now I can use that credential with a verifier. So verifiers could be anyone that wants to verify that the credential is authentic. The verifier knows or has a list of issuers it trusts. So maybe the TSA trusts a certain state's DMV. And so it'll see is the credential that you're holding issued by that state's DMV. So like trust triangle, the name like relies on trust. It's trusting that the issuer like because the issuer signed this credential, it trusts it. And yeah, it's just kind of overlaying existing trust relationships. So the next concept I want to talk about is authentication. So you guys probably heard this word before. It's part of digital interactions. Authentication is the process of verifying that a person or entity is who they actually claim to be. So lots of examples of this. So whenever you sign in with the username and password to access a website, you're authenticating yourself. You know both the username and password. If you are ever going to a DMV to be issued a license, you have to authenticate your identity by providing some other form of ID and multiple other forms of ID. This could be even multi-factor authentication. So, and like another example, which you guys have probably used before, is sign in with Ethereum. Sign in with Ethereum is a standard that we created here at Spruce, but it's really a community good. It's an open standard, open source, and anybody can use it so that you can prove you're in control of a public key by signing with the private key. So this is actually, signing with Ethereum is really important and cool because instead of signing with something like Google or Facebook, you are basically where your identifier could be taken away. I don't know if you guys, well, if you've used X or Twitter, the handle at X was taken away from the person who had it. And that's kind of antithetical to the ideas maybe that we, and the values that we share of kind of controlling your own stuff. So signing with Ethereum is a way that people can build applications where the users are still in control of their identifier. So by signing something, you can authenticate. So once you can prove who you are, you can authorize stuff. So the next concept I want to talk about is authorization. Authorization is a process of giving access or privileges to someone based on who they are. So some examples of authorization include, like, if a website asks for permission to access your Google Drive, you're authorizing them. Likewise, if you go to in person, you go to buy like a controlled substance like tobacco, you have to prove that you're over a certain age. And so if you give someone your ID, first they authenticate that it's actually you. They'll compare your face to the face on the ID. Then they'll look at the date to see, are you authorized by having the right age to buy the substance or the product. Another example is if you're a member of a Discord, you might need to be a member of the channel of the Discord itself to be able to view an announcement channel, while a moderator is authorized to post in that channel. So you have different permissions based on your identity. And something that we do in SpruceKit using Sign with Ethereum is basically authorizing an application to take actions on behalf of their user. So this is kind of an example of a super CW message, basically. And I'll actually talk about that in a little bit. But this CW message basically has permissions that the user grants the application to be able to read data. So yeah, we'll talk about and we'll see how we do this later today. The last concept I want to touch on is capabilities. So capabilities are basically a way to communicate the permissions that you have, that you've been authorized. So it's like a communicable, unforgeable token that grants permission to access something. So I'll actually talk maybe a little more about that last CW message we saw here. So when we sign a CW message, we can give permission to a session key, to the key we just created that can now take actions on our behalf. So this session key can now sign a message and include this original CW message as a permission slip. And so it can say, hey, I want to access this file. Here's a permission that the main Ethereum key gave me. And then I'm going to sign this request so you know it's actually me. So you know it's an authentic request. So capability is kind of like a packaged version of that. It has the original sign-in with Ethereum signature giving the key permission, and then it has the request that it's trying to make. So capability is just like has different forms, but it's kind of like it's basically an object that has all of this packaged nicely that's pretty interoperable. So someone can receive a capability, or a machine could receive a capability to understand and authenticate it and take the right actions. So yeah, so that's kind of some high-level concepts. Hopefully that was informative. And yeah, we'll touch on those concepts as we talk about SpruceKit. So yeah, what is SpruceKit and how should we think about it? So we're going to talk about it in the context of Zelda. I'm sure you guys have maybe played Zelda or are familiar with it. If you're not familiar with Zelda, it's a game where you're character Link. You're on an adventure to save the kingdom. You have to explore. You have to do all kinds of stuff. So right now at this hackathon, you're going on an adventure to bring decentralized identity, privacy, and security to everyone. And so what are your tools? SpruceKit. So let's dive in. So the first tool you have is sign with Ethereum. We also call sign with Ethereum seaweed. It's kind of like seaweed. So in case you've ever seen it online, that's how you pronounce it. But signing with Ethereum lets people use their Ethereum keys to authenticate themselves and prove that they're in control of an Ethereum account or an ENS domain. If I want to say I'm Vitalik.eth, I got to prove it, and I can't because I don't control those keys. But I can prove that I'm Gbafa.eth. So yeah, like I mentioned, no one can take away your identifier. And in our analogy for Zelda, it's our master sword. Signing with Ethereum is basically our main tool that makes us who we are, basically. So yeah. The next tool in the toolkit is SSX. SSX stands for self-sovereign anything. And it's a tool we've made at Spruce and we put a lot of thought and effort into. So Sign with Ethereum lets you authenticate and start sessions using, or SSX lets you authenticate and start sessions using Seaweed. It's a really easy way to put a lot of stuff in your Seaweed message. And it handles a bit of like the session key management, the creating of capabilities. So it does a lot. Some other stuff it does is it lets you access personal data vaults. It lets you manage how you like request user data, and it lets you also get credentials easily for your user. So again, we'll demonstrate that in a bit.
Sam, on that, we've had a question in the question channel which says,
sure.
Do you need to build your own backend in order to integrate SSX to your application for the sign-in with Ethereum?
You don't. So there are multiple ways to use SSX. You can use it with a backend. We also have multiple, I guess, SSX libraries. So we have something called SSX server, which lets you set up it's like a library for a server that lets you connect sessions if you want sessions. So the reason you might want sessions is if you have, let's say if you have a database that you want to say, this user has this data in the database, but you want to link that user using sign with Ethereum, you could use SSX to do that, but it's not required at all. In the app I'm going to demo, we actually don't have a backend at all, but we still are able to store and access user data. So, yeah.
Great, thank you very much. For everyone else, any more questions, please do ask away in the question panel. Thank you.
Yeah, you're totally welcome. You don't have to wait till the end of the Q&A. You can totally ask them now. Cool. Yeah, so after SSX, we have our library called Rebase. Rebase is a set of libraries that let us handle verifiable claims and issue verifiable credentials. It uses this idea called the programmable witness and self-issued credentials. So the witness basically can view credentials, issue them. A witness could look at a service like Twitter and see that you've posted and ask you to post something there. And if you post it, it could issue you a credential because it's verified that you had access to the Twitter account. So in our Zelda example, it'd be your Pure pad. It kind of lets you see and verify what's real. And our last thing, last slide, is Kepler. Kepler is something we've been working on at Spruce for a long time, and it's still in development. But it's basically allows you to store user data. It allows your users to basically pick who has access to the data, where it lives, And yeah, in this example, it'd be kind of comparable to an inventory. So yeah, we're gonna see what Kepler looks like basically right now. So yeah, with that, I hope you kind of learned a bit about what SpruceKit is and the kind of libraries that make it up, and a little bit of the capabilities. And yeah, we're gonna take a look and see what's possible. Cool. Before we do a demo though, let's talk about bounties, prizes, judging criteria. And I'll run through this really fast. So the first bounty, to let users bring their own identity and data to their app. I got 3 prizes. The first place prize is like the most innovative app use case. Because this is like like newer technology, new way of thinking, it unlocks a lot of new ways of being, but like new ways of like having applications. So we're really interested in like most like innovative app use cases. That one's our biggest prize. Second is the best technical implementation. Some of these libraries can be a bit tricky to use, and we want to see what you can do. So yeah, we'll reward the best technical implementation and also the best user experience. Because this can be new flows for people, and you will see some of those in a demo, we want to basically be able to, yeah, we want to see what you guys think from like a UX experience. So that's the first bounty. And the second bounty is basically letting people authenticate using their Ethereum accounts. If you sign in with Ethereum in your application, then yeah, we'll pick 12 of the best apps and we'll give them all a bounty. So what we will look for just in judging is just how good is your idea? Is it creative? Is it original? And like, yeah, does it leverage the unique things that are possible with SpruceKit? And the other stuff is like, how well is it implemented? Like, did you use the libraries? Did you just present a slideshow with no actual code? So that's another thing. And then also, what's the impact? With something like Kepler, which we'll look at later, if people can store their own data, they can give multiple applications access to the same data, and can kind of really build an ecosystem. So we're kind of curious to see what's the potential impact of what you made in terms of like an ecosystem, how it works with other stuff. Yeah. So with that, we're gonna switch gears and we're going to move into the demo. So I'm going to take a moment to set that up. And okay, I guess I'll move this out of the way and share my screen. And I'll share the entire screen. All right. In this demo, we are going to basically build what I'm calling a verifiable job application. So this is something where as it's almost like kind of like LinkedIn, but you control your data. It's kind of the idea. Built this like in the last few days. I was a mini hackathon to build it myself. So yeah, excited to show you guys what's possible. We're going to use Turbo ETH. I don't know if you guys are familiar. It's a pretty new and popular template, like using a lot of Web3 technologies. So I'm going to go ahead and create new project. So we'll start from scratch. I'm going to call it. I just saw a question: where's data stored at Kepler? It's not. There are no blockchains, and I'll talk about that. I'll talk about that shortly. But yeah. Okay, so Turbo ETH, name of the project, we will call it Encode demo. We're going to use just the starter template here. We're going to use Infura. You don't want to configure environment variables. We're going to use ETH mainnet, testnets, and yeah, we can solve dependencies. Let's make it. So while this loads, I want to show you a little bit what the finished thing looks like. So this is basically taking from just editing the template. So it's not like it's not like a very polished app, but the main point is to kind of demonstrate what's possible and how to add SpruceKit. I'm going to stop sharing while I type in my password.
Always a good idea.
Yes, to have operational security. All right, share screen again. Entire screen. Cool. Okay, so we have our nice sign with Ethereum button. And then I'm going to go ahead and sign in. And there's a lot happening. So let's break it down. Let's answer a couple of questions. And then let's also check in on here. So cool. We have our Encode demo repo. So I'll open that up in a bit. So right now, we have a lot going on. There's this message. It's a whole lot of stuff here. We got a URI. We have some other stuff, receive message. We have a really big resource. So let's break it down. So there's like a message, sign into verifiable job application. Then I further authorize this long did, which is actually the same thing as the URI here, to perform the following actions on my behalf. So you're basically giving permission to read in Kepler capabilities right here, and then to get list metadata for, we can look at shared / credentials, and then we can put get list for verifiable job application. So there's a lot of information here, a lot of text, but the main goal of this is a extension EIP to sign with Ethereum called Recaps, where we're able to understand what we're giving permission to. So this is the session key. We're granting this session key permission to do these following actions. And all of those permissions are also encoded here. So if we go ahead and copy this, base64 decode it, it's actually a structure that a machine could read and interpret. So we're going to go ahead and sign in. Let's get this out of the way. So we sign in, we're able to see my profile. If I want to go and edit this profile, I don't have any information on this. But Sam Gbafa, 123 Main Street, 3 4 5 6 7 8 9 0. So I can go ahead and just kind of drop in some info. If I wanted to, I could add employment history. I'm not going to do that. And then I'm going to update my profile. There's no update sign, but we'll actually add these pieces in our app, so we can kind of understand a bit more what's happening. So I'm going to go ahead and open the wrong place. All right. So just while we're here, to answer your question of where's data stored at Kepler. So Kepler is like database based. So Kepler is like a distributed storage system where you can host your own data, or somebody else can host your data, and data is kind of replicated. And so also for the demo, there's not a repo link yet. I will post it after the demo. And we'll share that in the Encode Discord. So yeah, Kepler is like a place where you create what's called an orbit. And I'll show you what that looks like. You create an orbit, and by creating the orbit, you're the controller of who has access to that orbit. You create it by signing a statement, and then anytime you sign a statement with your main Ethereum account, somebody else can access it. Or you're granting permission to someone to be able to access it. So the Kepler node will look at any requests coming in, and you'll see, do they have permission to access whatever. So no information is saved to the blockchain. What we use Ethereum for, and why signing with Ethereum is so kind of critical, is we use it for the key pairs. We're not, usually with a blockchain, you can take your Ethereum keys, you could sign a transaction, and then you could submit it to somebody who can take that transaction and build a block with it. We actually take those same keys and we sign statements saying this person can access this data, this person can do XYZ, and it's off chain. Anyone can like interpret these signed statements and do what they want with it. So there's no gas, there's none of that. So just to answer a couple of those questions, and let's also hop in the code. All right, so I'm going to go ahead and run the dev server. All right. While it loads, I'll continue to show the existing app. We have credentials here, and there's a question of like where these credentials come from. So these credentials are credentials that live in my Kepler orbit. I've issued them using the SpruceKit credential issuer, and then I can see them here. So the goal of this application is to fill out your app, select the credentials you want to include in your application, and then to be able to generate a submission and to submit it. So that's what this application can do. So that if I wanted to host my data myself in some future world where I have credentials, maybe from the school that I went to, from another employer saying I worked there for a certain amount of time, I'd be able to have those credentials live in a place I control, and then I could choose what I want to share if I want to send it off to someone. So that's the goal of what this is kind of modeling. So with this SpruceKit credential issuer, which is right here, it uses the same exact stack. So I'm going to go ahead and sign in. And I'll show you what it looks like to sign in with the account that you haven't used before. I'll show you that. I'll show that later, actually. So just because that's where you can see the orbit creation process. So right now I'm authorizing this app to access my Kepler orbit. Got the session key here. So it's going to be able to access shared / credentials, and it's going to be able to put stuff in there. So let's go ahead and sign in. And then I have like Twitter credential, I have GitHub credential. I'm going to go ahead and create another Twitter credential. So I'm going to use my main Twitter account because I think I added like an alternate Twitter account. I'm going to sign this attestation saying that I, Sam Gbafa, this at Twitter is linked to my Ethereum account. I'm going to sign that. So by signing with my Ethereum keys, we can verify the statement is real. We can look at the message, we can look at the public key, we can look at the signature, and see that, okay, the private keys to this Ethereum account sign this message. So once we have that signature, on the other side, we're going to go to Twitter and post this message. Twitter, open up my account. I'm going to pull it up here. I'm going to go ahead and paste this, and I'm going to post. And I'm going to grab this link. So copy link to tweet. And then I'm going to go ahead and paste the Twitter link here. And when I hit next, this is where a witness comes in. So we have a witness worker that is observing. It'll take two things. It'll take the signed message and the link to the tweet. It'll go to Twitter, grab the tweet, look at the contents of this attestation. So you can kind of see, they'll look at this signature here. It'll look at all this. And it'll do a comparison. And if it matches, it'll issue a credential saying that my address is the same as it'll just say it's the same address basically. I've now created that credential and it stored it in my Kepler orbit. So initially if I go back to manage credentials, initially I had this Frontier account, and then now I have Sam Gbafa. So maybe Frontier is my alt. I'm applying for a job. I want to use my official Twitter. I want to use my official GitHub. So the goal of this app, if I go and now refresh this, I'm going to sign in again, actually. Ethereum, go to credentials. We'll see now we have different credentials. So, and actually CSS could use some improvement. But basically, this did is the same as Sam Gbafa, and I want to include that one versus including Frontier. So let's say I want to include this as well. So so that's kind of a bit of how, like, that's the goal of this app, is basically to take that, right? To take profile information, credentials, and then if I generate submission, it kind of puts it all together here. So let's just dive into code just because of the interest of time. It's an Encode demo. So if we look at, so this is a new template. We are starting from scratch, blank server e-template. They have a sign in with Ethereum demo, which is basically uses, I'm going to go ahead and log out. It uses sign in with Ethereum. This is the vanilla library, the open source library. With SSX, we've done a lot of effort to really improve it. So yeah, let's go and swap this out for SSX. Let's try to connect to Kepler, and let's take a look at that. So, all right, so this is on integration, so I sign with Ethereum. So I'm going to go ahead and go to that. Integration, CV, can look at these components. Let's also go here, general integration. Okay, sign with Ethereum, great. So this is the page that has our logic for CV. It has it's signed in, has button logic. We're going to go ahead and copy this, and we'll make quite a few changes. So in thinking about the best way to go about this. So we're going to create a new in the integrations page, we will kind of change the functionality of the sign in with Ethereum button. So in order to add SSX, that's kind of the way we want to go about changing this. We want to make sure that we can have it in this React application. We want to make sure we have access to SSX throughout our application. So we're gonna go ahead and edit the providers. The providers. Let's see, components, providers, root provider. Great. So in React, you need to be able to a lot of your app logic lives within these nest of providers. If you're within a provider, you can go ahead and grab. You kind of have access as global context, and you can grab stuff. So what we want to do is add. We want to add SSX React to this application. SSX has a couple of libraries that make it easy to add. You don't have to use SSX React and React. You can use the just vanilla library. And so Yeah, pm add ID.
Sam, do you think
Yes.
you could zoom in ever so slightly?
Oh, totally. Yeah, I'll drink this.
Much better, thank you.
Cool. Okay. So cool. So we've added SX React. And then we can go ahead and add it to here. So we'll import the provider. That's tricky. And so what this does is we put it within RainbowKit. So RainbowKit connects to the Ethereum provider in the browser, in the browser window. So SX provider here, we're going to close it, go ahead and close it. And we also need to provide some configuration. So this is where, let's see, I'm going to pull it up on another window so I can easily copy and paste it. Okay. Right. So, oh, I realized I actually did it slightly differently. So let's do it slightly differently here too. So I'm going to go ahead and create a new folder called SX provider, or a new file, tsx, and SX provider. I'll just copy and paste in the interest of time. So we want to grab the wallet client from WAGMI. We want to grab the provider, SX provider. I'm renaming it just to prevent a slight conflict because we're also exporting a provider. Here we have our SSX config. And this is like one of the, this is a pretty important piece of using SSX. The SSX config is how you enable, how you edit your CV message, how you access kind of the properties of SSX. So for example, the CV config, if you look at the vanilla CV library, you're able to pass parameters to change each of the fields. SSX will take some initial parameters, including like the statement, like nonce, stuff like that. And if you add modules, for example, if you add storage, it'll also go ahead and add like a session key. It'll like manage the session key. It does a lot of additional functionality just by adding a few flags. So here we add the storage flag. It has prefix. So the prefix is the folder within storage that you're accessing. So this application accesses like verifiable job app. It could be the name of whatever your app is that you're trying to access. Credentials equals true. There are many options here. So instead of true, you could pass other like a config object. But basically, this will also like get permissions to grab their credential. And when your user like hits sign in, they'll get a CV message that actually is a little more complex, but grants your application the right permission to be able to access that data. And another really cool flag is the resolve ENS flag. So I know ENS has a bounty during the Encode Hackathon as well. And just by turning this flag on, you get the ability to say ssx.sessions.ens, and then you can grab any ENS data that's available. So the goal of SSX is to kind of really simplify a lot of the complexities down to this configuration object. And basically by configuring this, you can then use ssx.storage.get or ssx.credentials.list and kind of a simple API to be able to grab and access these really powerful capabilities. So yeah, so SSX React provider basically now gives you an SSX object that you can access in other parts of the application. So let's go ahead and see what that looks like. So if we go to SSX, so now SSX provider, we're going to go ahead and pull in our root provider. Instead of pulling in SSX from our SSX React package, we're going to pull it in from just next door. Import. I think that this is this. Okay, components lib. Just gonna copy this. And so yeah, so now we have SSX provider, and in our application, we can now use the React hook to grab it. So let's go up to our integration here. So I think in my other application, I just actually replaced this entirely. So let's see if I can do that here. In the interest of time, I'll also look at some of these questions. Yes. So with SSX, you can automatically resolve, your wallet address to, you can resolve it automatically. So, or like, I guess really with the function call. So you get if you enable that, basically like when someone signs in, we fetch the data from ENS if it exists, and then you have it accessible throughout. It's accessible on the SSX object. It also works with, it's the same with like Lens protocol. You can also fetch the data the exact same way. And then, Spruce can be used with an Expo React Native project, like SpruceKit can, because it's a JavaScript library. It should be, there may be some compatibility issues that we're working on with Node, with a pure Node versus a web library. But yeah, if you're working on that, definitely reach out in the Discord, and we'd be totally happy to support any issue you have. Great. So I think just in the interest of time, I'll just kind of show like the working version right now. Great. So there are a couple of things. We have this app context that lets us, here we are able to call, so app context is, it's another provider. We have our layouts. This dashboard layout is the same layout of this page here. So if I'm like, it describes like the side panel, it describes top panel, and describes this inner space, which is where a lot of the other, which is where these pages live. So credentials page, the profile page, the submit page, they all live in here. So zooming out in this layout, this is where we do some stuff with SSX. There's a provider that lives at this level that is app context. And so we're basically able to, when we log in for the first time, we do this fetch profile. So if SSX doesn't exist, we reroute back to the landing page. We set an initialize flag for true, just in case this function is called when we don't want it to be called. And then we go ahead and we do some stuff like ssx.storage.get profile. So because, let's see, I'm going to close others, and we'll open up where the provider is, SSX provider. So we can look at both the config and what it enables. So because we have storage and because we specified the prefix, we're able to get this profile. So if we actually inspect the traffic when we start this application, we can go ahead and inspect. Okay, let's look at the network traffic. Shrink. Also, sorry for the size of this. Okay, so I'm going to go ahead and sign in with Ethereum. So here I sign in, again, granting permission to the session key. There's also a new session key each time. Session keys can expire. They're basically, they're just temporary keys we create to grant temporary permissions to. Great, so now we can, oops. Great, so we see a lot of these invoke calls, and let's take a look at one. Oops. I usually use a larger screen, so it's a little tricky to take a look at this. So if we just grab one of these, the base64, if we look at this authorization, I guess this basically is our signed request from our session key. So if we PWT.io, we could just kind of take a peek at what's inside. So this looks like it's a Kepler put. So we're this is not a great example. Basically what I want to show was us getting the profile and what we get back in return. So we make a request and we grab the profile. We make a request to grab the credentials that you selected. So basically, when I hit update on the profile page, I put there we go. I'm doing ssx.storage.put, and I'm now putting the data that's here. So if I want to say Spruce, like I worked at Spruce, and SpruceID, and I'm an engineer, and I go ahead and fill this out, and I hit update. It's going ahead and storing this in Kepler, and another application could grab it if it knows the exact location. It could list, it could see what's there, it can inspect if it has permissions. And then, so basically, in the context, we're grabbing all of our stuff from Kepler, grabbing profile, credentials. We're listing the credentials that are available, and we're kind of reformatting them a bit so that, because they're just basically in a list, they're prefixed with the type of credential and an identifier, and then the actual credential itself. So we just reformat it so we can list them together, grab the GitHub credentials, grab the Twitter credentials. If there are other credentials, like let's say I had 4 different email addresses, I could get all of those in here and I could select each one that I wanted, and only the one I wanted to use for my job application. Great question. I just saw. How do users give permissions to their data? I will talk about that momentarily. But I think for just in interest of time, in the interest of this workshop, I will publish this repo, and also we'll probably just have it hosted on Vercel. If you want to play around with it, we'll probably clean it up a little more. But I'll also highlight, like just in comments, like where we use SSX, like why we structured stuff. And I would definitely be open to any questions in Discord about this. And so with that, we can maybe move into more Q&A. And I'll start with, how do users give permission to their data? So right now, it is kind of a newer approach, what we're doing. And it's kind of, it's a little tricky from a UI perspective to allow users to like edit the message. So for example, if let's say an app requests that I want read and write permissions to a folder, and I only want to give read permissions to that folder, how does a user specify that? So right now, with Kepler and SSX, you can't do that. You can only like either say yes or no. But we basically have an approach in mind where a user can kind of reject the message and present an alternate message that they want to send. So if I reject it, I give like, actually, these are permissions I want to send. And then that's what's granted to the application of SSX. So as an application developer, you can say, you can kind of configure your permissions you want, you can request it, but you have to know that if I go to ssx.storage.get profile, that actually might fail because I may not have get permissions. So it kind of changes the relationship between a user and an application developer. And that application developer has to consider, what if I don't have permissions? And the ability to further request permissions. So that's something we're thinking a lot about, like, how do I make it easy as a developer to say, I want to get this, ask for permissions, I don't have permissions, and then continue. Kind of like if I'm using an app and it asks to access my camera, like I have to say yes, right? A developer should be able to say somewhere deep in their application, like logic, I want X permission. And maybe it's a new CB message that shows up that's saying, hey, by the way, like, please grant permission for X. So that's kind of where we think a bit about like the UI and UX and all that. So, yeah.
Amazing. Sam, thank you very much for such an interesting discussion. Obviously, I'm aware that you've answered many questions throughout the call, but if anyone here does have any remaining questions, please do feel free to ask those in the chat. Sam, I wondered if I could perhaps ask you a less technical question. Obviously, being a university hackathon, many people here are just at the start of their journey into Web3. And so I wondered if you could perhaps talk about your own journey into Web3, perhaps where you first heard about Web3, and yeah, just any tips that you would have for people looking to get into the industry.
Sure. My journey, I think maybe just first heard about like Bitcoin. I've been out of college for a few years, but I heard about Bitcoin when I was like freshman in college. I was like, what is this? And then I don't know, just kind of got in and out of interest, I guess, just based on even maybe market cycles. But I think I got really interested in like, how do we actually use this technology from like a non-financial perspective? Like, how can we control other stuff? And like partially even when thinking about like AI, like how can we use cryptography to like send like kind of like verifiable, like to show that, hey, this is like real, this is like maybe a real bit of information or some real data versus like something that's generated. So I think that kind of I just really got an interest in like cryptography and like how can we use crypto and blockchains for like kind of non-financial stuff, and kind of led me to Spruce. I think I was just like trying to answer that question and literally ran into Wayne, one of the co-founders of Spruce, and so that's kind of how I like ended up here. But I think if you're a university student and you're definitely trying to like break into Web3 or learn more about it, I do think it can be maybe kind of a bit of a, I think for one, doing hackathons like you're doing now is like super excellent because you get to like see the technology and use it and talk to people building it. And then also if you can go to like in-person hackathons near you, there are ETH events all over the world. I think those are really great places to meet people that are also interested, that may like, because Web3 is really connected, really personal. And I think just kind of also being in person is like a really, really great way to get in the space.
Amazing. Thank you so much for that. Whilst you are answering that one, we've had another question in the chat. So how does Siwi work with ENS subdomains?
ENS subdomains. So if I remember correctly, ENS subdomains can be tied to an Ethereum address. So I believe if you, and I'm saying I believe because I haven't tested ENS subdomains exactly, but I believe it should work the same with the resolve ENS flag. So if you have a subdomain tied to your Ethereum account and you hit resolve ENS, let's see. There's ways. There we go. Cool. So right now we're looking at the types for the we're looking at the types for like the configuration. So if we go ahead and look at the ENS flag, basically the fields that are provided is the domain and avatar. The domain field should just have the subdomain if you have one tied to your Ethereum account. So yeah, but yeah, resolve ENS should just basically make it work. And let me see if I show you where we use that, or an example where we use it. Great. So this is like an example. So SSX here and I know we're coming up on time. So here we use SSX because we turned on ENS flags way earlier in our application. We can say ssx.sessions.ens.domain. And if we don't have the domain, if it doesn't exist on the account we're using, we just default to the address. And so, yeah.
Amazing. Loic, I do see you've got a follow-up question, but I'm very conscious of time, so I wonder if perhaps we take this to the Discord channel.
Let's take it to Discord.
Yeah, hopefully Sam can answer that for you there. But Sam, once again, I'd just like to say thank you very much. A really great session talking about first principles, giving insights into the bounties as well. Yeah, I'm sure everybody is feeling very clued up on that now. So thank you very much to our participants as well. Thank you for some amazing questions. Yet again, it's really great to see you. Just a quick reminder, in half an hour, we have our second workshop of the day, which is an overview of the Arbitrum DAO and how you can get involved. So I'd really recommend that one as well. But for now, Sam, thank you very much. And yeah, we look forward to seeing you all soon.